divided by polynomials. And the things that we're going to do with our rational functions are the same kind of things we do with every other function. We're going to find the domain, we're going to find the x-intercepts, we're going to find the y-intercepts, and then the new stuff for rational functions. We're going to find things called vertical asymptotes,
Love it.
if there are any, horizontal asymptotes,
Love it.
if there are any, and slant asymptotes, if there are any. It could be that your rational function has none of those, so we'll have to find out. Finally, we're going to, if we have vertical asymptotes, horizontal asymptotes, and x-intercepts, we're going to build a rational function just like we built polynomials from x-intercepts. And there's one word problem involving rational functions, which we may or may not get to today. So let's just start with this rational function right here. How do I find the domain of a function? How do I find the domain? Use your 5 questions. The domain questions work for any function we get in this class. So here's my rational function. The first question is, does it have a denominator? And the answer is yes. So I take my denominator, negative 2x minus 5 times 7x minus 2, set it equal to 0, and solve. Now, the next question that comes in your domain function questions is there a square root or an even root? Rational functions will never have those. Is there a logarithm or natural log? Rational functions will never have those. Did we get this by finding an inverse? We are not dealing with inverses in rational functions. And is this a real world problem? Well, we might run into one of those, but for the most part, this is the only thing we have to deal with. So, I now have my negative 2x minus 5 equals 0, which gives me negative 2x equals 5, which gives me x equals negative 5 halves that I need to remove. Over here I have 7x minus 2 equals 0. This gives me 7x equals 2. So x equals 2/7 will need to be removed. So how am I going to remove these 2 points from everything?
You need them.
Negative infinity to negative 5 halves, because it's the smaller of the 2 numbers. And then what do I put?
Right.
A parenthesis, because parentheses indicate not included. And then I will continue on with, where do I start next?
Negative 5 hours.
Negative 5 halves. Again, a parenthesis, and then go to 2/7. Since it's not included, I do a parenthesis, and then again 2/7 to infinity. That's how I remove those 2 points. Now, what about finding x-intercepts? How do I generally find x-intercepts when I'm dealing with functions? Put 0 in for y, in this case, f of x. So 0 equals 6x minus 2 divided by negative 2x minus 5 and 7x minus 2. All right? How do I solve this?
Gotta multiply the top and the bottom by the denominator.
Right, if I multiply both sides by the denominator, that'll help. Or if you're not seeing that because you're not as comfortable with that, if you think about this as being 0 over 1, you have a fraction equal to a fraction, what can you do? You can cross multiply, and you'll end up in the same place. If I multiply 0 times its denominator, what do I end up with?
0.
0. And if I multiply 1 times the 6x minus 2, what do I end up with? 6x minus 2. So then I can solve 2 equals 6x, and 1/3 equals x. Is this number okay? How do you know it's okay and I can use it as an x-intercept? Well, you want to come back and look. Is it in my domain?
Yes.
Yes. As long as it's in my domain, we're set. So 1/3, comma 0 is my x-intercept.
So you don't have to do anything with the bottom?
The reason the bottom went away is because when I multiplied 0 times the
Oh.
bottom, it became 0. So it made it very nice. You're like, okay. It looked really messy, and then it turned out not to be so bad.
She just skipped it all. Cut
What
stuff.
about y-intercepts? Put in 0 where? Put in 0 for x. So here I'll have f of 0 equals 6 times 0 minus 2 divided by negative 2 times 0 minus 5 times 7 times 0 minus 2. What will that leave me with? In the numerator I
1/25.
have negative 2. In my denominator I have,
50. 10.
how'd you get 10?
So 150. Negative 5 times
This is
negative
negative 5, because that's 0, so negative 5. This is negative 2, so negative 5 times negative 2, which will give me negative 2 over positive 10, which is the same thing as negative 1/5.
2. That's right. I told
And
you
how will
that.
that look as, what is it, y-intercept?
0, negative 1.
0, comma, negative 1/5.
That pen's running out.
Yeah, that one is. Now, we already knew how to find denominators, we already knew how to find x-intercepts, and we already knew how to find y-intercepts. The new stuff has to do with vertical asymptotes and horizontal asymptotes. So let's talk about how we find, well, what is a vertical asymptote? Anybody know what a vertical asymptote is?
If you read, yeah, probably.
So we get close to a number but never reach it. Nah, what kind of number are we talking about? Yeah, we don't talk about limits in here.
But where like X approaches, but does not come on.
What kind of line?
Top
A vertical
of the book.
line.
What do you mean we don't talk about it?
So vertical asymptotes are vertical lines that are not actually part of the graph, but what happens as your graph approaches them is it comes up to them and either heads off to infinity or down to negative infinity. It never actually runs into the line. And then in the case of our rational function, your graph will continue on the other side of that vertical line, either coming down from infinity or coming up from negative infinity. But it will never actually run into that line. That's what a vertical asymptote is. So how do you think we're going to find vertical asymptotes? Any suggestions? Anybody know? Not exactly the power on the bottom.
0.
It's the whole bottom. Vertical asymptotes occur when an x value makes your denominator equal to 0, but does not make your numerator equal to 0. If it makes both of them equal to 0, then there's other things that come in. So we need to find out where our denominator is equal to 0. So we're going to take our denominator, negative 2x minus 5 times 7x minus 2, set it equal to 0, and solve. So I have negative 2x minus 5 equals 0, and 7x minus 2 equals 0. Here we get negative 2x equals 5, so x equals negative 5 halves. Here we get 7x equals 2, so x equals 2/7. Am I done?